live. Okay.
Are we live?
I think we are live. Yes, we are
yeah,
live. You can check it, and you can even set the link on YouTube. Scala Process. Yes, welcome. If anybody's, yeah, please. If people are joining, welcome. We today have a very busy schedule. First part, obviously, I'm going to just introduce some organizational changes that we agreed upon, which have to do with going forward, and then I will let the SIP committee discuss the features we chose to speak about today. So there was a discussion last time and in the meantime about streamlining the process because we already finalized one part of going through the features in the last year. And now we are trying to figure out what would be the best process to follow in the next year until the release in end of 2020. And the committee agreed that it would be the best if each committee member would, in a way, own a certain number of features that they would either champion or try to poke holes, to quote some of them, with the or both. It goes yeah. So with the goal to make sure that the features are refined, or so to say, to raise the red flags now when it's time to test it, to try to break it, and do everything to play with it until the point of refinement. Also, another goal would be to have detailed reviews, especially for the contentious ones, and have a straw poll by the committee within the next year for each feature. We are obviously going to be still involving the community in these discussions because it cannot be done in a vacuum. So you will see conversation popping up and given the time of a month to discuss and so forth. So it's more or less very similar to the previous way we have been doing things. But this time, just that the difference is that the committee members will invest more time on their own to make sure that they dive into the features and play with Scala 3 in a different way than just discussing about it based on different documents that were around. So that's my part. I would now let Sebastian go over the 3 features we chose basically for today, and I'm very sorry about last minute feature discussion.
Okay. Hey, Daria, I'm sorry to interrupt, but I was just sending out the video link, and I clicked on the link to check it, and the video is just of me.
Yeah.
So many questions.
So, because that's how is this better? The 3 features we chose basically for today, and I'm... You need to mute your mic. Very sorry about... Thank you. It's your face was there because your mic was on, and that's why you were in the first... So basically, that's that. So we had the meeting not long ago and many things in the meantime. So the agenda came a little bit late, and I'm going to let this hour be more about technical things. I'm always open for questions. How did we come about this process and so forth in Gitter, or you can send me an email or whatever works for you, because I would really like to focus now more on technical side, because in the last 2-3 times we were really trying to figure out what's the best way going forward, and now it's the time to start going forward. So I open the stage for that. Let's go.
Okay, so we'll discuss hopefully 3 things. So first, I'll say that the given so implicit redesign, all that stuff, contributors thread is still ongoing. We'll I'll keep it open a bit more. Okay. So this is still ongoing, and please keep looking at it. Some changes were made recently, especially for conditional givens instances. So have a look at it. Now today we're going to start the discussions on three things. Hopefully, one is open classes or sealed class by default, explicit nulls, which were just merged into .e, and hopefully admin methods, if we get there and if someone can talk about it. So we'll start with open classes. So the gist of it is that we have three kinds of classes. A class can be sealed, in which case you can extend it in the same file. It can be final, in which case you cannot extend it, or it's neither, and it can be extended from anywhere. That's typically problematic for at least library authors who then by accident leave classes open, and then that means you cannot evolve the class in any way without breaking someone's code somewhere. So here the idea is to introduce basically a fourth category, which is an explicitly open class. That one says, it's a strong signal that says, I have intended this class to be open and extended, and I have thought through all of the contracts of what it means to override every method with what contract, what are the impacts of that. And then if you leave a class without either of open, sealed, or final, it means, well, I didn't really, I haven't done all the efforts that are needed to make sure it makes sense to extend this class, but I'm not preventing anyone from doing it either. And the idea would be that by default there would be a warning if you extend a class that's not explicitly open, and you can disable that warning with a language import. So the feedback that has already been happening in the contributors threads, I summarize it in two categories of people. The people who like this very much, and which I think, which from the names I've seen, seems very highly correlated with the people who are library authors and maintainers, and the people who are like, oh, but you're taking away the ability for me to patch up libraries by extending and overriding some methods, which are which I, from my subjective analysis, seems to be correlated to people who are application writers. And generally my argument to that would be, well, if you're patching up a library that's because you want to fix it up for your own code, we have not taken away the ability to do that. You can still do it, it's just a compile warning, and you can even silence the compile warning with the proper language flag. So to me, it's an overwhelming yes, I'm hugely in favor. But I know that some people in the committee do not completely have the same opinion. So I think I'll start with giving the mic to Julian, maybe.
So my concerns were that it's most likely the case that a lot more application code is out there. So the concerns of application writers should be weighted perhaps a little bit more than library authors. It seems to me that library authors are generally more advanced users of the language that could potentially use final when it's needed, or sealed. And perhaps the question is, if everyone else is going to add this compiler flag in their applications, is that sort of a good default then to make them to require this open keyword if everyone is going to circumvent it? So that said, I think that the fact that there is a way to sort of keep their existing behavior is not bad. There's precedent in Kotlin, I think. There's the same requirement to define a class as open. I had a second remark. I think that the current proposal for enums and ADTs perhaps covers a large percentage of this. I mean, I think open classes, or so let's say closed sealed classes by default, are very useful when you have case classes. So a simple ADT. So perhaps there's a middle ground where ADTs have this behavior and maybe not all the other classes.
Martin, do you want to say something about that?
I'm not sure. So I think most people will continue to use normal classes, and maybe for case classes, yeah, maybe they will. But I have the impression there are lots of application areas where people will continue to use normal classes. I have the impression that we have found actually a very good compromise with the language import to sort of balance the thing that library writers want to sort of be protected and want to clearly communicate what could break or what could not break in future versions of the language, and users who essentially want still maybe sometimes to override. But in that case, I think what would happen now is, hey, they would get a warning, and there's a way to make the warning go away with the language import. So I think that's really sort of super soft, but we essentially we define a contract between library writers and library users, which is more helpful than the one we have right now, where essentially a library writer has to either accept that essentially people will override the class and everything could break, or has to be paranoid and make everything final, which means that some possibly good use cases, for instance mocking tests, would be prevented. So I find that essentially the current one, where essentially you have a default that says, well, I didn't bother to write an inheritance contract, which is in 95% the case of the cases that's the case. I would say people don't bother to write inheritance contracts, and then that should be clearly communicated, and that should be the default, because that's the most common thing.
Yeah, it's worth noting that inheritance contracts are much more difficult to write and to think about than usage contracts, because now the fundamental difference between a usage contract and an inheritance contract is that in a usage contract you have to define what happens when you call a method, and every public method. In an inheritance contract, you have to define not only what happens when you call every method, but also very precisely describe when will every public or protected methods, when will those be called, and what it means to override them in the flow of internal things that can happen within the class. There are so many more moving parts. It's really crazy. So typically people don't think about the inheritance contract at all, right? Unless it's very specifically designed for it.
So I have one quick question and one comment. The quick question is, non-sealed classes, just no modified classes, how does the exhaustivity checker, does the exhaustivity checker start considering those sealed classes? And the comment is, if I'm as a library author, if I don't have final, is adding final a breaking change? Because it's a breaking change for any of my users that use the language flag. So I guess it's just as breaking as adding final today, I feel like.
So I think so first, I don't think exhaustivity can change here. So exhaustivity would reason about it just as much, in the same way that it works for open classes. Because if you want exhaustivity, then you would see it explicitly, right? That's probably the normal thing to do. And then the comment was, sorry, can you remind me right now?
Yeah, so as a library author, right now I'm, making something final is a breaking change.
Oh, yeah, right.
So right now it's the same. Like,
yeah, so making something final would be breaking, but you could explicitly make it sealed, which would be source breaking, but not binary breaking, because the JVM doesn't know about sealed. Yet. But I don't think that's really the point. So it's worth noting that and entering it into the set. But the point here is, if it's the signal that is sent outside to the users of the library, that if you extend this, you're on your own and you are exploiting something that was not intended. So you are on your own and you are exposing yourself to at least potential source breakage. And depending on the guarantees that this particular library provides in terms of binary compat or not, then you might also expose yourself to binary compat problems. It's really the signal.
So I have two comments I guess I want to make. So one is the fact that the default is to open inside the current file is pretty arbitrary. It makes sense for C for implementation reasons, because the type checker has to know about all your children, so if it's in the same compilation unit, it just makes things easier. But here, like all the examples, everything we're talking about is I write some code and then there's some other code written by someone else in another project that uses my code, what happens. So this is all really at the project level, not even the package level. And so I think if we could have this thing be at the project level, which is a bit tricky because it's about compilation and stuff, but would give much, like it would be much nicer for application developers because they will basically not have to care about this at all. And it will also work for library authors. And the other thing I'm concerned about is the use of language flags or language imports. Because typically what happens is people see a warning, they're like, oh no, not another warning, let me silence that. So they do dash language, colon, whatever. Then they never see the warning ever again, and they don't have to think about it ever again. And which also means that we get basically dialects of the language, because you look at the code and you don't know which flag they pass in their SBT build, and you have to be Turing complete to interpret the SBT build, so it's hard to see anyway. So you don't know what's going on, like what kind of style am I reading. So like one idea would be, okay, when you extend a class which is not open, you have to be more explicit, to do extends, like force extend, or some keywords, some syntax at the extension point. So then when you look at the code, first you don't have multiple language dialects, you just have one language, which is here, and then you don't have an import or flag that everyone forgot about, but you have directly, the point where you do something weird, you have syntax.
That won't work for the mocking aspects. So in an application, like if in an application that uses mocking-based testing, you want to enable that on all your testing code, basically, because your mocks wants to extend things like that all the time.
So I'm not familiar with mocking libraries, but do you do by hand, you do new, full, whatever, or you
no,
it's
typically a macro that creates a class
so if it's a macro, the macro can generate the tree that does the right thing.
Could be, yeah. So I think we've discussed this enough as an initial startup of this. We'll open a contribute. Well, there is already a contributor
Yes.
for that, but we will.
Should we do?
A new one.
I don't know.
Because the proposal evolved, like the original proposal didn't have the import, for example. So
Yeah, and I would suggest a sequel because it did change a lot, and so my reaction to, my initial reaction was very negative, and the current version I'm up to sort of deeply skeptical.
Okay. Okay. Yeah.
I would I just want to say briefly, because we've been talking about different forms of this, and I just find the whole thing so questionable. Like it's like it seems to me like an area where everything was fine. This wasn't anyone's big pain point about Scala.
It is
The
my
only
main point about Scala. That and nulls. Like this is
Yeah.
what trips me up every time I write a library. Every single time.
But I mean, the fact that you have public code guides, you said you must put final on every case class and things like that. I find
So-
shocking because it means that we have public code guides that said you have a very verbose and boilerplate Scala style that gets promoted because of the lack of this feature.
So I would like to explore whether we could somehow restrict the change to just case classes, and I don't know if that was discussed, but when I hear people talking about Scala, they do complain about and sort of laugh at this thing of case classes not being final, but I don't hear that for a final by default, but I just don't hear that about normal classes,
Yeah, but yeah.
except from SEP.
I don't know. I've been complaining about that for years in hallway tracks, but never in public because I could never find any reasonable path forward anyway. Now that I see this path forward, which I have never thought about before, I'll be happy to start complaining more heavily. Yeah. Okay, I suggest we close this up for now, and we'll then open a new contributors thread explaining the current status and some of the alternatives that we discussed now, and so formally open a round of review for this one, or public review. So then I suggest we move on to, my other big pain point, turns out. The nulls, yeah, it's just the resistance. So explicit nulls has just been merged into Dotty. Was it yesterday or this morning?
Monday.
On Monday. Okay.
It's old now.
It's very old, so like by Dotty's merging standards, it's almost obsolete. So here, of course, I don't think I have to tell anyone that null is an issue. Every reference type is basically nullable, so you can put null in it, and Scala and its type system don't protect you against null pointer exceptions everywhere. And the idea here is to fix this. So the basic idea is to say, well, if you have a reference type like string, it is not nullable. So you cannot assign null to something that's of type string. Then the next question is, how do I write down a nullable type? And the obvious answer is use a union type, because we already have a type for null itself, and we have union types, so string or null is very obviously a string or null. That's it, basically. And then there's all the tail of consequences from that. One big consequence is Java interrupt, obviously, because if you want to talk to a Java library, it has reference types, and they might be nulls. And the library might even demand nulls or return nulls as signals of nothing is here. But at the same time, many of the Java types are not, in fact, nullables in practice per API. And so there is a tricky balance between when you talk to these Java libraries, do you translate every reference type to string or null? And then you have to deal with it with ifs or pattern matches or some sort of flat map API all the time in Scala, even though you know by contract that this thing is actually not nullable, so this is very annoying. And the other thing where you say, well, if it comes from Java, make it non-nullable, and then, well, then you don't have any kind of checks anymore in practice. So here the proposal, and it's one of its delicate points, of course, is to say things that come from Java, they are a bit special. A string that comes from Java is neither string nor string or null. It is string or unchecked null. And that has some properties, like you can dot select on these things, for example. But you also have some, so yeah, it's something in the middle.
How in the middle? What can you not do?
What you cannot do is, well, it's that to, at the point where you transfer that to something that's just string, then it will eagerly fail at that point if it's null. That's the idea. So if your Scala API declares I'm returning a string, and you call to implement that, you call a Java API and it returns you a string or unchecked null, then it's in the body of that method that it will have to throw a null pointer exception. Like it can't give the null away. It cannot pass the boundary of the Scala API that's not nullable. That's really the cornerstone here. The other big thing is that there is a lot of code that writes if x equals null, then do something, else do something with x that assumes it's actually not null. And here the idea is to introduce some form of flow typing, which can prove, in fact, that in the else branch, my x is in fact a string. So if it was a string or null before, and I do if x is null, well, then it's null, and in the else branch, I know it's a string. So that's it for the main things here. So I'm going to open that for comments now.
Right, so I think
I'm really enthusiastic about this, with the possible exception of the flow typing. Like, it seems odd to me to introduce that in such a limited way. Like, it seems like something that either the language should go all in on or not do at all.
Yeah, it's a very valid concern. I'm not entirely convinced myself. The question here is how inconvenient would it be if we didn't have the flow typing for all the legacy code that does that? So let's be honest here. If it weren't for legacy codes, we wouldn't even have come up with flow typing for this particular case. Well, we would do pattern match. Like we would write pattern match, and if it's null, do something, and otherwise it's a string. And,
for imperative algorithms, so really low-level, high-performance imperative algorithms, they have a lot of noise for performance reasons.
But the pattern match would compile down to the exact same thing.
Not have a pattern match, but really an each channel or something like that. I think. So essentially, low-level imperative code uses this a lot. So basically, every other language that did this has some form of float typing. So that I don't think any language introduced explicit null without float typing, but it would be risky to do that, to say the least.
Yeah, I think Kotlin mentioned that two algorithms actually too. I think every language that does that has two things actually. They have the typing and they have the XD separator question mark dot. So you don't have to actually write
Yeah, so actually I wanted to ask about that. So what's the recommended way to call methods on nullable types? Basically the equivalent of the Elvis operator.
Well, you don't, right? Because you have to first test whether it's null. If you want to have something that like pushes the null later, well, the recommended thing is don't. And if it's really what you want, then do the if else. It's because the thing that is very, very dangerous with the Elvis operator is that the simple explanation is, or the naive explanation is to say, well, Elvis is like our flat map, so why don't we offer flat map for nullable types? But the problem is it's not flat map because it confuses the equivalent of none and sum of none, right? So that seems like a very theoretical thing, but it really boils down to practical things. Like if you have a map and you have a get method that returns a nullable of the value, well, this is really bad if you instantiate the value type to something that is itself nullable, because now you cannot distinguish those two things anymore. And the Elvis operator encourages these things to flatten out in that way, and that shouldn't happen in typical codes. You don't want to like silently push nulls later. If you actually want to do that, then actually do it and spell it out, because I don't think in idiomatic Scala code this will happen very often.
Yeah.
Well, I mean,
Martin, is that, or go ahead, Julian.
No, I don't have anything to add. I'd be surprised though to see this feature being as useful. Well, it is useful. It adds type safety around null. I agree at the edges of your application, but I would guess that most people would actually want the Elvis operator, or else would rather than use an option and do flat map. Because right, you can't do anything with an nullable type right now. You can't call any method. The only thing you can do is call NN, which would throw null pointer exception in the standard library, or do an if then else, which is halfway, I would say. Because so to me I understand the argument about flat map not being the same as the Elvis operator. To me, it seems though a little nice thing to have if you go down this path. So I didn't go through the contributors thread though, so I don't know what the feedback was from the community so far on this.
There hasn't really been an open discussion yet on that. So this is the bootstrapping right now. I don't think there is a contributor's thread on the topic.
I have a question around the equality, both equals and eq. Is there a reason? Is there any big wins on making those error when comparing to null?
So, well, first, if the type tells you it's a string, why would you try even to compare it to null? So it's the same as trying to test, is it an int? The compiler currently tells you, well, no, obviously it can't be an int. So here it's the same, it's protecting you against useless tests. That's the obvious answer. if the type tells you it's a string, why there is no valid reasonable code that would test is it actually null? No, it cannot be. The type tells you that already.
Modular initialization, but we have something else for that.
Yeah, but if something is null because of initialization issues, your program is already flawed, and the fix is not to test whether it's null.
No.
The fix is to fix the initialization, right? So that also does not happen.
I remember Corky Cartwright said a long time ago, he taught everyone basically null is not evil, but you should never ever test for null, equal null or not equal. If you slavishly adhere to that, then your program will be okay. So you should use null only for undefined, but never to figure out whether it's undefined or not. Because say, well, I don't care to put a value in here.
Yeah, that's interesting. Any other comments, Adrian or Lucas? If Lucas is still there.
So right now this is Erlander.
People in the community is active. In the comments.
So I'm going to read out some of the comments online. So at some point, Morgan PHP says, agreed, pushing nulls further out just makes it harder to diagnose NPEs. I am not sure what that was referring to.
So if you use the Elvis operator.
Oh yeah, if you use the Elvis operator, yeah, okay. So then Naftali Guggenheim says, did anyone suggest an extension method to go from a or no to option or something like undef or? So undef or is the undefined or a that Scala.js has. And Eugene answered, how would option.apply work? I'd like to be null as none. Yeah, I'll come back to that one. So the extension method to go from undefined or null to option, well, it's actually the same, the same question as the next one. It is option.apply. So option.apply, or option parentheses x, takes an a or no and returns a option of a. That's it. So if you receive a string or null from something like a Java API and you call option of x on that thing, type inference will very nicely unify the a with string, and you will receive an option of string. So we don't need an extension method. It's already the option apply method that does that basically, which in my opinion should never have behaved like that. It should be option dot from knowable, but that's the way history made it. So it's called option dot apply or just option parentheses.
But maybe one could argue that it should be an extension method for better flow of the.
Then, if you have a lot of flow like that, define your own extension methods. Now it's one line of code to define such an extension method, so probably doesn't need to be in the standard library.
I don't know if you have NN, it's kind of makes sense to have the safe equivalent.
Yeah, so about NN, yeah, I haven't talked about NN. So NN is how is it? It's an extension method. Is that right? I don't know how it's implemented, but basically, if you have a string or no, you can call x.nn for not null, and this is kind of asserting right there that it's not actually null, and it will throw a null pointer exception if it's actually null, and otherwise it returns a string. To be honest, that's one part I still don't very much like in this proposal. At least the fact that it's like available everywhere by default. I think it's a bit of a stretch. I'd like to at least have to import this thing.
It's like how people complain about having get on option.
It's
That it's too easy to.
it's very similar to .get on option. Yeah.
I would actually defend both get and NN.
Mhm.
If you don't like them, don't use them.
Yeah. No, I mean, I will probably not
Sorry,
use
can you
them.
can you move the mic? Can you move the mic closer to Martin and Guillaume?
Yeah, I said I'm a proponent of both get and .nn. If you don't, I believe they have actually many use cases, and if they don't fit yours, and in your use case you don't like to use them, just don't use them. I don't believe we should make life more complicated for everyone else. I believe importing our current code we will use .nn a lot. That's maybe after some binary releases of Scala 3, people will use NN less, and we can maybe at some point deprecate it or move it somewhere. But for the moment, I have the impression it's the obvious thing that we need to do to port it.
Martin, I wanted to ask: is is that happening only in performance critical code? Where you're using null for performance, or is that just one of the cases you need this?
But it comes up basically whenever you do Java interop or really low-level performance critical code. It's the two major areas I see.
And doesn't the unchecked null cover the Java case?
Yeah, unchecked null. Well, no, that only works for directly. So basically, the Java case only works if you directly interrupt. So you have a value like system.out from Java, and it's print stream or unchecked null, so you can still call the print on it, which is good. But as soon as I take anything from Java and put it into my own value, so I put a Scala type on it, at that point I have to choose. I have to choose, is this essentially a string or null, or is this a string? Or I could use unchecked null, but probably I wouldn't typically. So it's sort of when I deal with, basically if Java, let's say I use Java util map for whatever reason, or concurrent hash map for whatever reasons, and it uses nulls, and maybe I will continue to use null in that code, not even if the code is not terribly low level.
I think an easier way to answer the question is that, so the unchecked null, it works when you select a number on it. But you cannot assign, or I think you cannot assign a string or unchecked null to a string.
No, you can't.
So it's, if you want to store it in a string, the unchecked null will still be checked for that thing. So then you have to call .nn if you want to store it in a string. That's
so yeah. This unchecked null seems to me like so. The motivation behind it is to allow unsafe selections, which typically people would use the Elvis operator for, which I think is probably slightly better, right?
So Kotlin went through all that with a lot of things. So they first had Elvis, but it means that literally every time you write system.out.println, you have to write system.out Elvis println, and nobody's prepared to do that. So in the end, they relented, and they essentially came up with something quite similar called platform types. That is essentially their analog of our unchecked.
But again, I think we agree that most, or maybe we don't, most nulls come from Java code. And if most nulls are unchecked nulls, and we're indeed catching nulls that people write in Scala, but those are very few, is this, I would say, I don't know, strict enough or useful enough? So system out println, I think it's actually fairly rare that people write. I think they most likely would use console.println in Scala or a logging framework.
Yeah, there are many other things where you say, well, Java didn't guarantee that it's not null. By all practical means, it's null and nobody checks for that. No, you don't want to put everything in there. So system out println was essentially the paradigmatic case where this happened. I mean, it simply Kotlin took years to get this right, and that's what they ended up with. So we shouldn't discard that out of that.
Sure. I mean, I'll definitely check what Kotlin did, but I still find this as a serious or a very easy way to turn a blind eye on null scale. So I would say this would probably still generate lots of NPEs. Because I think it's very easy not to realize that these are unchecked nulls. Right? You're calling some Java method, perhaps a Java util collection method gets, and then you continue. And I guess you don't get any warnings or anything at that point.
Yes, but as soon as you pass it to some like a Scala type, in Scala, when you write in Scala string, it means string and nothing else. So that's basically your firewall.
So there's one important thing here I think we mentioned is with this proposal also comes a bunch of annotations for like the Java standard library, which are supposed to know like for all the methods in the Java standard library, which one actually takes null or return nulls, which will improve the usability probably. And in that case, like for things which actually return null, like maybe like the get on collections, I think then you get an actual or null and not an unchecked null.
I don't know that part. I don't know. Okay, good point.
But so given that the unchecked null, I guess, is mostly useful for like third-party libraries which don't have annotations, which don't use @null null or something like that. So yeah, if you use @null null in your Java code, then Scala can understand that. It's mostly. It's tricky actually because there's no standard @null null, so everyone has their own annotation.
So one thing I thought about while discussing this in the hallway the other day would be that maybe so some people cry out at this unsoundness as oh, we're digging unsoundness here and I don't want that, and I'm not talking to Java that much. I really want everything to be checked, and maybe it's some I don't know. Again, language flags are bad, but maybe we can have a language flag that disables the magic quality of unchecked null. I don't know.
I'm curious about the status of the -y flag to opt into all of this. Is the intention that will eventually be on by default?
Hopefully, yeah, if it works out.
So what
Okay.
my view on that would be to first test it like this for a while, and if people find it useful, then actually make this maybe part of essentially the Scala 3.1, so basically 3.1 version, maybe already under the future flag, and turn it on by default in 3.1. That would be sort of the aggressive schedule to do that.
Yeah, so the whole compartment migration thing is very tricky because this is a language flag, you can like have a library which enables it, and then you can have user code that uses this library, which doesn't have it enabled. Or you can have a bunch of libraries which some enable it and some don't enable it. And it's not that very clear to me how this all interacts.
So Andre's position was in Scala code, if this thing is not enabled, then basically you take it on you that you will not mix string with null. So that string means string and it's not, then it's unsound. And to prevent the unsoundness, well, everybody should turn on the flag, or eventually in a future version we would have it on by default, and then we could. So that's I think that's probably the most practical approach to it.
So I'm going to voice to recommend this online. So Eugene says, yeah. So someone first asked about normalizing the volume. I'm sorry, we're trying to move the microphone closer to the people who are speaking, but sometimes really mess it up. Then Eugene Yokota asks, what about var excellence string equals underscore?
Yeah, that's a great.
It's evil. We should have removed that from the language.
No,
decades ago.
It's quite the opposite. So essentially that is that should be not treated as an implicit assignment of null. That's not what it is. It should say that I take this variable to be undefined. So I want that variable, not an abstract variable, but a variable that is initially undefined, and the initialization checker should check that in fact this variable will be defined at each point before I actually use it. I think that's the right way to look at it. So I'm basically declaring this variable is undefined, and I'm open to automated checks that the variable will be assigned before the usage. And that I think the use cases. If you force people to write equals now, then basically you hide that error thing. Then its type must be string or now, and you wash out the type.
If you do have an automatic checker for that, then yes, then that's the obvious answer. Then it's not.
Because in a way, this is a thing which changes its type. It starts out as string or null, and then it becomes string. Again, don't represent that.
The copy thing to upgrade the initialization checker to keep track of that. That would be a good.
It doesn't actually.
I'm not sure.
Another question is from George Blumer. Have we considered using a similar mechanism to Kotlin's platform types, where users basically get to very easily assert Java code's nullability? Well, basically, the unchecked null is our reification in the type checker of what Kotlin's platform types are. So yes, this is not only has this been considered, it is basically the same thing, just expressed in different ways.
It's really interesting to actually describe in detail the difference between these two approaches.
But the difference is Kotlin doesn't have union types, so they had to do it with a built-in feature, and we have union types. It's the obvious answer. I don't even can't even start to argue why this is correct, because to me it's so obviously the right thing to do that.
Right, but does it change things in practice? Does it have different semantics?
That's a good question. Somebody who knows Kotlin better should.
As far as I can tell, well, probably in the minutiae of the what you can do with a platform type and what you can do with an unchecked null, there might be differences. But in the in the explicitly nullable in Kotlin versus our explicitly a or no, there is no difference. It's the same thing.
Well, we don't have a good ergonomics on using T or null, like an unboxed option.
You shouldn't have good ergonomics, because for ergonomics we have option, and that's the right way to deal ergonomically with something that is actually type parametric, so you will not get tripped up by the flattening of the nulls things. So if you want ergonomy, use an option that still hasn't changed. This is still the right thing to do for most Scala code. If you are using a nullable thing, it's either because you are temporarily talking to Java, and then probably the unchecked null thing is the normal way to deal with it, or you are doing performance critical code, and then, well, deal with it. This is actually the best part about this thing, is that codes that wants to be performance critical and that does use null for this particular purpose gets help from the type system to do so. Whereas before we did not get help from the type system to do so. I have comments in my source codes that says this thing is actually nullable.
Yeah, me too.
But then I have to deal with it on my own. And now I'll have the help of the type checker to help me write my performance critical code more correctly.
Yeah, I guess I'm sort of arguing for U option, the unboxed option.
So now that the unboxed option, that's an entirely different question, but I think we're running out of time. I'm happy to rediscuss this offline on the contributors thread that we will open very soon, and this will be the official beginning of the. So yeah, it's 3 to 6 now, so we have to come to a close. But yes, I have a solution for that.
Cool.
Too long to fit in this margin. Like Fermat, right?
But yeah, so there's unless someone has very last words, but otherwise we'll declare this meeting adjourned. Daria, do you want to close up? Or?
No, it's, so we have essentially these two things to put
Yeah,
out
these
now.
two things to push
What about
out.
the third one we wanted
So,
to discuss, main methods?
yeah, main methods. So maybe we'll also
Should we still do that, or?
I mean, we can open the contributors thread and open the open
Okay.
discussion.
I mean, if you don't mind, you can just say like
Yeah,
what
the-
it is,
So the,
so we have it for the record, and like
Okay.
we invest another couple of minutes.
So the gist of the main thing is that delayed init is gone so far, and the obvious question is what do we do with for a very simple main methods, and now the idea is to have basically an @main annotation, and then you write sort of def foo that takes even parameters, and then you write the body inside. And since we have top level functions, you can put that at the top level, and it's even better, and everyone is happy. There are details, of course, but we'll lay that down in the document.
We should assign people to lead the contributors thread.
So I think the right thing to do from now on for those things is that the champion should open the contributors threads. I definitely volunteer to champion the explicit nulls and the open
Okay.
classes.
we need a champion for the main methods.
But I'd like someone else to do the main methods.
Anybody championing main methods?
Volunteers, come out,
Nobody
come out,
wants main methods?
wherever
Um,
you are.
I could take that one.
Okay,
Aw.
good. Thanks, Chris.
Super.
So sets will
Okay,
open
cool.
the contributors threads. Okay.
Okay.
Thank you.
So,
Elena,
yeah.
for,
Yeah, there was one more comment. I don't know if it's.
So someone said, love the explicit null idea, but I can't help wondering how much work this require in the real world, as we'll still use lots of Java-based library. It's not activated by default, right? No, it's not activated by default at the moment, and when it is, the unchecked null is the answer to the Java interrupt. So,
But even with that, it's not clear like how
It-
it's just
yeah, but
We'll
we'll
see
discuss
what
this
happens.
further in the future.
Okay, so thank you all 15 people that are watching for your support and for all the comments. I love that. I wish everyone on the call a Happy New Year and all the holidays that are coming. See you in January, and 2020 is going to be a very exciting year from the SIP committee and obviously from the community as well.
Do you have a date for January? yet?
Not yet. I'm going to set it up
Okay,
tomorrow already. So.
that's good.
And then for just for the community also to know, we will meet. The committee will meet in March for the 3-day retreat again. And yeah, so January, February are going to be online, and probably in March we will have an hour as well to summarize what's happening. So thank you everyone. Thank you all the members also for all the time
Bye-bye.
and effort.
Bye-bye,
And
thank
let's
you.
do this.
Okay, thanks. Thanks very much.
Happy holidays.
Happy holidays.
Have a good break, everyone.
Ciao. Now I need to stop streaming. Just a moment. It's
don't say your passwords out loud.
yes, please. Now is not the time.